So I've gone a long ways to describing my equilibrium. I just need one more equation that'll satisfy equation 3. What's missing so far? What ingredient? You should be able to guess what's missing. What's the piece that I haven't described yet? I've described how input costs affect price. I've described how price affects output. And I've described how inputs have to change to produce the output. What piece of the economic equilibrium in this industry is missing? Yeah, any notion of cost minimization is missing here, right? That is the idea that the firms are choosing L and K to minimize cost, while implicit in these other equations I haven't explicitly expressed here. I haven't captured that. Economists measure substitution in the two-factor case using a concept known as the elasticity of substitution. Usually you use the letter sigma. It measures how much factor inputs respond to changes in factor prices along that isoquant, right? Draw the isoquant and ask how do inputs change as we change output. As we change factor prices. Now, the nice thing is with constant returns to scale is all the isoquants look the same as long as I'm moving along a ray. Right? As long as I'm holding either factor ratios constant or factor price ratios constant, same story. As long as I move out along that ray, I'm going to get the same elasticity of substitution with CRS. There's no change in the elasticity of substitution. So we're going to think of the elasticity of substitution as delta L over K equals sigma R over W. And this is where economists, I made it little r, big R, doesn't matter. That's a rental rate of capital. So this delta L over K equals sigma times delta R over W. And there's a little trick in this formula that on the left-hand side I got L over K, and on the right-hand side I have R over W. That just means sigma is going to be positive. That's the trick economists did to make sigma positive. Because there's really a negative relationship between factor prices and factor price ratios and quantity ratios, because demand slopes down. But we define the elasticity of substitution as the change in the factor ratio as a percentage of the change in the factor price ratio measured the opposite way. So if a 10% increase in R over W leads to a 5% change in L over K, we would give you elasticity of substitution of a half. So for some well-known production functions like Cobb-Douglas corresponds to sigma equals 1. Right? Cobb-Douglas is sigma equals 1. Okay, that's the elasticity of substitution. And many things in economics are going to turn on whether that number is bigger or less than 1. One's a nice dividing line. Okay? So in terms of my notation, this implies delta L minus delta K, which is delta L over K, equals sigma delta R minus delta W. That's going to be my equation 3. Delta L minus delta K equals sigma delta R minus delta W. And you notice again, I got L minus K on this side and R minus W on that side. I've done that same flip, where I'm measuring labor to capital on the left and capital labor on the right. Okay?